we're all either rational or irrational. So going back to the P's over Q thing, if you need to find your zeros, you want to start by trying to find your rational zeros. Connor, hand me that sheet of paper. Because we're doing notes now.
Yeah.
This is why I never give your spirals out at the beginning of class. Ugh. Okay. So what are your P's over Q's? Tell me my P's, Ryan. Okay, list them for me. Oh, can you go in order? Like 1 in and 48. Two and 24. 2 times 24. You see what I mean by order? I'm doing like pairs. Yep. Perfect. These are all the factors of 48. Yeah, but your Q's are all 1. So that makes life better. That's because you were absent and you didn't watch the video.
Oh, yeah.
So we're going to list our P's over Q. It's obviously all the plus or minuses of those. And then we're going to cheat and use our calculator to actually start with something. Cheating. True. But like my advanced pre-calculus kids literally have to start doing random synthetic division for, and they blindly pick of those however many there are. They just have to start going through. I don't know. Tedious stuff builds character. All right, pick one. Pick one to start with. -3? 2? Be careful of 2 because it is a double root. So we're going to have to divide out 2 twice. But that's fine. We can do that. Well, those are your only 3 roots anyway. In order to get this down to a quadratic, we're going to have to synthetically divide out all of them anyway. So let's start with -3. It's just because it's not a double. I'm going to have to do all 3 of these anyway, but because you have to keep doing synthetic division until whatever power you're on gets down to an x squared. Yes, really. You're going to see why in a moment. Okay. So, as of right now, it's down to x plus 3 and x to the 4th minus 4x cubed plus 8x squared minus 16x plus 16. Now I'm going to continue factoring. Good morning. I'm going to continue factoring this polynomial by synthetically dividing out the next root that I see, which is 2. But I'm using these numbers in my synthetic. I don't want to go back to my original. I don't want to refactor off of my original. What I'm essentially doing is I'm factoring my remaining piece. So we're taking out a 2. I stole it from my calculator again. I have that root of 2. Well, I can see that it's not a double, so why would I? Right? I know it's not going to work a second time.
So
Ooh.
you only divide it twice if it's a double? Like the 2?
Correct.
So if I started with 2, I go with 2 again?
Correct. If you started with the 2 and it worked, which you know it's going to because you looked at your calculator, then you would do a 2 again after that because you see that that one's a double. No, we're continuing to factor this piece, so when we do our synthetic to take out the 2, we're going to pick up with that piece.
She's sweating. Wouldn't it have been funny if I had my
Isn't it
head
funny
up?
kids think that?
Yeah,
Oh, so who was nervous?
Oh. You would have been nervous if I had my head on.
Yeah, no one noticed. Thank you, JR. That was very sweet of you.
I would
Hopefully he doesn't watch this video. I'll tell him to tune in. All right, so now I still have the x plus 3, and I have further factored this one into an x minus 2. And that was a 4th degree polynomial, so this is now down to a 3rd. Well, sometimes. It depends on if that 4-term polynomial is factorable by hand or not. I don't know, is it groupable? Because if it's groupable, you can take advantage of that. If you didn't want to even bother with that, you could take out your 3rd and final root that we see, which is another 2, because that was a double. You could pick up synthetic from here and take a 2 out of that, and you'd further factor that down. Yep, because it's a root of 2 twice. Yes. So I'm going to assume that most things, just so you see it, most things are not going to be groupable at that moment. So I'm going to do this one more time with synthetic. You can group it if you want, but I'm just going to show you this. So now my cubic is finally down to a quadratic of x squared plus 4. So remember that we had a degree of 5. Those 5 degrees are still accounted for. Here's 1, here's 2, here's 3, here's 4 and 5. I have 3 linears, which is 1, 1, and 1, and a quadratic, which is 2. That adds up to 5 total. So all 5 roots are accounted for. So they want f in factored form, which we have. They also, so that's one part of the answer. The beginning of this, though, said find the zeros. So we actually need to tee all of this up. 3 of the 4 of these factors are pretty easy to tee up. Agreed? You get x equals -3, 2. You don't have to list 2 twice. And then the last one is the only one that's a little bit tough. If you tee this up and then solve it, so subtract 4 from both sides.
Plus or minus 2.
Nope. Plus or minus 2i.
Okay,
Right.
gosh.
So, unfortunately, the only way you can find your imaginary roots is to strip out all of your real roots with that long division, and then once it gets down to a quadratic, just solve that quadratic totally separately, and that'll give you your 2 remaining imaginary roots. Does that make sense? Or your 2 remaining irrational roots if it happened to be a quadratic that was like x squared minus 5, where you'd add 5 to both sides, square root both sides, you'd get x equals plus or minus root 5. That's still a real root, it's just irrational, so it didn't show up on your P over Q list. Follow? So we have 4 zeros, but really all 5 are accounted for because this one was a double. Questions? Make sense? Okay. Sarah, what are my P's? Good. Brock, what are your Q's? 3 and it's the factors of this. 1 and 3. So your list is going to be a little bit longer. You've got 1 over 1, which is 1, and 1 over 3. You've got 18 over 1 and 18 over 3, which is 6. you have 3 over 1, which is 3, and 3 over 3, which is 1. I don't need to rewrite that. 6 over 1 is 6. I don't need to rewrite that. 6 over 3 is 2. 2 over 1 is 2. 2 over 3 is 2/3. 9 over 1 is 9. 9 over 3 is 3, and I don't need to rewrite that. So, go to your calculator to cheat. To see where synthetic should start. Mike, what do you want to start with? Okay. And what's your other option? 1/3. You didn't have to trace it to figure that out, right? You could just tell based on your list compared to where it crossed, right? If you had a 1/3 and a 1/2, maybe you'd want to just double check that that's exactly what it is. But yeah, so if we start with -2, oops. Uh-oh. 54? I was stumped at my times tables there. And so right now we're at x plus 2. And then we were a 4th degree polynomial, so now we're going to be a third. So 3x cubed minus 1x squared. And then, would you look at that? This one's groupable too. So maybe I don't take out my 1/3 now. Maybe I show you the other way. If you want to do synthetic with this and pull out 1/3, go for it. The issue with pulling out 1/3 though, let's do it because 1/3 is funny, and I don't think we've talked about this yet, even though you did it last year. One-third, 27,990. So what factor is this? You remember how to change a fractional root into a factor that contains only integers? Like I can't just write x minus 1/3. It's easy with whole numbers because you can do that. Does anybody remember? Yeah, good. How'd you do that? Or how does your, I don't know. Yeah. Right. So you probably, well, to kind of, well, you just proved with the right answer why it is 1/3, but like you still didn't really explain how you, did you just guess it? She got good gut. She explained how if it is 3x minus 1, how it then she adds the 1 over, but how did you just, you didn't just pull that out of thin air?
Well, that's the way I thought about it.
So you sort of guessed and checked and kind of figured out what would work. So if you go backwards from, like, again, if your root is a whole number, it's easy because you're kind of, what you're doing technically is you're going backwards from teeing it up. And so for something like this, if you're going backwards from teeing it up, you would multiply that 3 over first, and you'd get 3x equals 1. And then you would subtract the 1 over, and you'd get 3x minus 1 equals 0. So if you do have a fractional root, make sure you know how to turn it into a factor. And then this is finally 3x squared plus 27. And then we still have that original factor of x plus 2. So just make sure at this point that you don't forget anything, that all 4 roots are accounted for, which they are. So there's my factored form, and then I need my zeros. So my zeros are -2, 1/3, and then this one I'm going to actually have to tee up and solve. So subtracting 27, dividing by 3, and square rooting. Well, you should know, well, if you don't see these additional roots, then you know they're imaginary.
I know, I keep forgetting that, like, when it's negative, when it's radical, that it's...
Right. The one thing, and I'm going to start you like 95% of the way through the process. Let's say you have a 5th degree polynomial, and you've got it down to this. Something like that. Once you've kind of stripped the first 3 linear factors out and you're down to a quadratic, those 2 quadratics that those 2 problems left us with, you could just tee it up and kind of isolate the x. You can't do that if it's a trinomial quadratic left, right? So if you tee this up, you can't just move something over and square root both sides anymore. How do you have to solve that? Using the right, which again might produce 2 irrational or it might produce 2 imaginary. It kind of depends on what's going to happen with your discriminant. So that's 5 plus or minus the square root of 25 minus 40 is -15 over 2. 15 can't be broken down, but the negative gets pulled out, so it's 5 plus or minus I root 15 over 2. Still conjugates, right? So your final 2 solutions are a little bit more complicated imaginary numbers. These are still conjugates, it's just a lot simpler. So if the quadratic you're left with is a trinomial, like most quadratics are, make sure you just tackle it with the quadratic formula because you're isolating and square rooting both sides not going to work. Sound good? I'm going to give you back your quarterlies. Ryan, will you pass those out?